Okay, so in this section we're going to talk about the quadratic formula. This is probably maybe the most famous formula in algebra. And we want to do three things. Number one is answer the question, what is the quadratic formula? Secondly, how do you use it to solve an equation? And then thirdly, there's a part of the quadratic formula called the discriminant. And it's important because it tells us something significant about the equation, specifically how many solutions it's going to have. So we will talk about what that is, how to find it, and what it means. Okay, this is the quadratic formula. It's right here, and underneath that is a URL for a link. It's kind of a humorous song that goes to the tune of "Pop Goes the Weasel." It's a helpful way for people to remember the songs. If you search that "Pop Goes the Weasel" quadratic formula song, might be a way to help you memorize it. Math is not primarily about memorizing, but this one is so important, it's used so widely that you may as well just have it committed to memory. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here is a proof of where that comes from, because it's nice sometimes to know not just that a formula, not just to know what it is, but basically where it comes from. So the proof is based on completing the square, which we did in the last section. So on the right side, I'll complete the square on this equation with actual numbers in it, and the left side will do it with the variables. So the first thing we do in completing a square, the 1 right here is not working for us. It's not going to factor. So we'll move it over. And so we get 2x squared plus 8x equals negative 1. Same thing over here. The c is not going to factor, so we will move that over. And we get ax squared plus bx is equal now to negative c. Okay, over here we can't complete the square until the number in front of x squared, until this number here is 1. Since it's not 1, we'll make it 1 by dividing everything by 2. And when we do that, we get x squared plus 8 divided by 2 is 4, and that equals negative 1/2. Same thing over here. A is not going to, we need a to be 1, so we're going to divide everything by that right there, and we get x squared plus b over ax equals negative c over a. Okay, how do we complete the square? Well, the key step is we take half of this number, which is 2. Half of 4 is 2. We take half of that, and we square it, and we add that to both sides. Okay, so same thing over here. We take half of this number. What is half of b over a? 1/2 times b over a, that would be b over 2a. So that is exactly what we will square and add to both sides. b over 2a, that whole thing will be squared. Okay, this on the right side with the numbers, this is now a perfect square. This can now be factored. It's going to be x plus 2, and again the 2 came from half of that number, equals, and then negative 1/2 plus 4, well 4 is like 8 over 2, so negative 1 over 2 plus 8 over 2, that would be 7 over 2. Same thing over here, this can now factor, it's a perfect square, it's going to be x plus b over 2a. Where did that come from? B over 2a is half of that number. And you might remember from earlier in the chapter we said the vertex always occurs at negative b over 2a. The reason why is negative b over 2a plugged in there would make that whole parentheses equal to 0. Over here we're going to have negative c over a plus, and then b over 2a, the whole thing squared would be b squared over, what's 2a squared? 2a times 2a, that would be 4a squared. Okay, and then we have a fraction here. In order to add fractions, we need a common denominator. So the common denominator of a and 4a squared would be 4a squared. I have to multiply that by 4a, multiply this by 4a, and then we would get the following. We would get negative 4ac, because that's where that comes from, over 4a squared. 4a times a is 4a squared, plus b squared over 4a squared. Okay, then let's just combine that into a single fraction. So we would have x plus b over 2a squared, and then I'm just going to reverse the order. I'll put the b squared in front, and then the minus 4ac coming second, and it's still all over 4a squared. Okay, back to the numbers. How do we complete the square? We square root. We already completed the square. We square root both sides and put a plus or minus in front. Squaring and square rooting cancel, so we get x plus 2 equals plus or minus 7 over plus root 7 over root 2. Last step is we subtract 2 from both sides, and we get this. And that's not wrong, but we could simplify that a little bit further, because root 7 over root 2, you can do something called rationalizing the denominator, which means multiply top and bottom by the square root of that number. Square root 7 times square root 2 is square root 14. root 2 times root 2 is 2. So the final answer here for x would be plus or minus root 14 over 2, and that's what x is equal to. Okay, on the other side, let's just clean this up a little. So on the other side, we're going to do the same thing. We have to square root both sides, and then put a plus or minus in front. We have x plus b over 2a, and again, these cancel each other out, equals plus or minus this thing square rooted over this thing square rooted. And what's the square root of 4a squared? The square root of 4 is 2, and the square root of a squared is a. So we can actually just take that bottom square root and make that 2a. You can't do that on the top because this is not really b squared, it's b squared with this other stuff attached to it. So we're not able to do anything with that. Very last thing, we want to solve for x by subtracting b over 2a from both sides. So our final answer will be, notice we have a common denominator here, so we can combine them into one. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So what did we just prove? We just proved that the quadratic formula is true, and that it comes from completing the square. So it's interesting to know just where that comes from, the fact that somebody didn't just make that up, but there's actually a proof for it. So how do you use the quadratic formula? Well, first of all, you always need your equation to be in this form right here. You always need it to be in standard form, which means it equals 0. This doesn't equal 0, but we can make it equal 0 by subtracting that 11 over. And then my biggest recommendation with the quadratic formula is you always start by writing out what a equals, what b equals, and what c equals. Because if you get this part right, there's a very good chance you get the rest of the problem right. If you get it wrong, there's almost no chance that you get it right. So there is c. C, remember, is this number that doesn't have any x attached. So c would be negative 11. You have to take the minus with it. This number here is minus 10 and negative 10. That's b, because b is the thing attached to x. And then our a value is this number in front of x squared. And in this case, there's just a 1x squared there. So a would be 1. Okay, once we have it, I mean, that's most of the challenge of the problem, is just correctly identifying a, b, and c. Here's the quadratic formula. It's negative b plus or minus the square root of b squared minus 4ac, and then all over 2a. It's important that everything, including this thing right here, you put over 2a. Sometimes people forget to do that. So I'm going to plug in where b is supposed to go. It's negative b, or b is negative 10, so negative 10 plus or minus the square root of b squared, that's negative 10 squared, minus 4 times a times c all over 2 times a, so 2 times 1, and again c would be negative 11. And from this point, all we need to do is just simplify that a little further. So negative 10 is positive 10, plus or minus the square root. Negative 10 squared is 100, minus, and then 4 times 1 is 4, times negative 11 is negative 44, so we get 100 minus negative 44, and that's all over 2 times 1, which is 2. Alright, so let's clean this up a little. So we have 10 plus or minus negative 44 is like plus 44, so 100 plus 44 is 144. And then that's going to be 10 plus or minus 12, because that's what the square root of 124 is. And at this point, what we should do is split this down the middle into two different fractions. So we're going to have 10 over 2 plus or minus 12 over 2. Well, that's the same as 5, because that's 10 over 2, plus or minus 12 over 2 is 6. And then we can do 5 plus 6, because that's one solution, that equals 11. 5 minus 6, that's another solution, that equals negative 1. Those are our two solutions for x. And you might have noticed at the beginning that we could actually have factored this right here. X squared minus 10x minus 11, that actually factors to this. It factors to x minus 11 times x plus 1, and it means that would be 11, and that would be negative 1. And that's what we found using the quadratic formula. Okay. What if you had something like this? So in this case, a would be 1, b would be 8, and c is 16. So negative b would be negative 8 plus or minus the square root of this number squared, 8 squared, which is 64, minus 4 times a is 1, times c is 16, all over 2 times a, 2 times 1. So let's simplify that. We get negative 8 plus or minus. This whole thing right here is minus 64, so we're going to have the square root of 64 minus 64 all over 2. That's going to be negative 8 plus or minus Well, that's the square root of 0, and the square root of 0 is just 0. Okay, so this is what we're going to talk about later, something called the discriminant. The discriminant is this number right here. And negative 8 plus 0 and negative 8 minus 0, that's the same number. That's just negative 8. So we get negative 8 over 2, which is negative 4. And we only get one answer in that case. Sometimes that can happen. If you get 0 under the root, you may only get one answer. Alright, let's take a look at this one. So in this example, A is 2, B is 6, C is negative 7. So negative B would be negative 6. Plus or minus the square root of b squared, so 6 squared, minus 4 times a, 4 times 2, times c, times negative 7, that's all over 2 times a, 2 times 2. So we have negative 6 plus or minus the square root. 6 squared is 36, minus, and then 4 times 2 is 8, 8 times negative 7 is negative 56. So we have minus negative 56, and that's all over 2 times 2, or 4. Okay, so let's simplify this out. So minus negative 56 is like plus negative 56. 36 plus 56 is 92, and that's all over 4. Okay, now 92 is not a perfect square, so here's what we need to do. We need to basically take 92 and simplify it by using these list of perfect squares and see is there something that we can pull out of 92. And the only thing we can pull out of 92 is 4. So we're going to have 4 times, root 4 times root 23. And root 4 is 2. The square root of 92 is the same as the square root of 2 times, regular 2 times square root of 23. So we're going to have this. And then the last thing we can do is just split this down the middle. So negative 6 over 4 plus or minus 2 root 23 over 4. 6 over 4 reduces to negative 3 over 2. And then the 2 becomes a 1 when we cancel it, and that 4 becomes a 2. So we have root 23 over 2. And that's as simple as we can make it. We can't simplify that any further, so we stop there. Alright, last type of solution you might see is what if you end up with imaginary numbers. So first we need to put this problem in standard form. You get x squared minus 6x plus 10 equals 0. A is this number, so A equals 1. B is this number, negative 6. C is that number, 10. So we have negative b, negative 6, plus or minus the square root of b squared, or negative 6 squared, minus 4 times a is 1 times c, which is 10. And that's all divided by 2 times a, 2 times 1. I want to emphasize again, this fraction bar goes over everything, not just the square root part. So now let's simplify this. Negative 6 is positive 6, plus or minus the negative 6 squared, that's 36, minus, and then 4 times 1 times 10 is 40, so minus 40. 36 minus 40 is negative 4 over 2 times 1 over 2. Let's split this down the middle. We get 6 over 2 plus or minus square root of negative 4 over 2. What's the square root of negative 4? Well, you could simplify that to be square root 4 times square root negative 1. The square root of 4 is 2, and the square root of negative 1 is I. So that's the same thing as 2i. So 6 over 2 is 3 plus or minus 2i over 2. And 2i over 2 is just I. So there is our final answer. That's an imaginary solution. So we saw every type of solution we saw when the b squared minus 4ac part, because that's what's under the square root. We saw when that was a positive number, which means it's greater than 0. We saw it when it was equal to 0. And we also saw it when it was less than 0, when it was negative. Okay, so basically what is this thing right here, the b squared minus 4ac? The name for that thing is called the discriminant. And the reason it's important is because when that's a positive number, your solution is going to have, you're going to have two solutions. Here's why. Negative b plus or minus, imagine that this thing is a positive number. Okay, if that's a positive number, so I'm just going to make up a random number for negative b and 2a. Let's suppose you're doing an equation, you have these numbers in the equation. And let's say that turns out to be the square root 25. So that means 25, just the thing under the square root, that's called the discriminant. And let's say you have that over, I don't know, we'll say 6. What this is going to end up being is negative 4 plus the square root of 25, which is 5. That's going to be one solution. The other one will be negative 4 minus 5 over 6. So this is going to give you two different solutions because this is a positive number. That's what that table says right there. If it equals 0, If it equals 0, you're going to have, let's say, negative 4 plus or minus the square root of 0 over 6. Again, you just emphasize these numbers, negative 4 and 6. I'm just making these up. Whatever problem you happen to be doing is probably going to have different numbers. So what is negative 4 plus 0? That's negative 4. What's negative 4 minus 0? That's still negative 4. So you're just going to end up with a single solution. And when you graph it, it's just going to touch once. This first one that has two solutions means it touches twice. Finally, this last case is when you have an imaginary solution. So we just did one with the square root of negative 4. That right there is an imaginary number. You're not going to have a real solution. You're going to have two what are called complex, or two imaginary solutions. Okay, the only other thing I want to mention before we find the discriminant is what's the difference between two real rational roots and two real irrational roots. Here's the difference. If b squared minus 4ac equals one of these numbers, if it equals one of these numbers right here, it will be rational. And what's the significance of those numbers? Obviously they keep going forever, 49, 64, and so on. Those are perfect squares. Rational means that you can take it and get a nice even number. Square root of 25 is 5, square root of 36 is 6, and so on. Okay, what would an irrational number look like? Two irrational numbers would be something like if you had 5 or 6 or 7 or 8 or 10. Basically anything that when you take the square root of it, you're not going to get a nice clean number like you would for those perfect squares. Alright, so let's find each of these discriminants, and then we'll tell what kind of solution it has. So A right here is 7, B is negative 11, and C is 5. What is the discriminant? The discriminant equals this. So we just need to plug these in. So B is negative 11 squared, minus 4 times A is 7, and C is 5. So negative 11 squared is 121, minus 4 times 7 is 28, 28 times 5 is 140. So when we solve this, we get negative 19. So that means when you're doing the quadratic formula, you'd have a negative 19 under here, which means you'd be taking the square root of the negative. So there's going to be two roots, but they will be two imaginary roots, because you can't take the square root of a negative number and get something real. Okay, this right here is A equals 1. Back to using different colors here. This is B, that's 22. And then finally here is C, and C is 121. So here's the outline. We have B squared minus 4 times A times C, and we want to know what does that equal. So B is 22, 22 squared, and that's 484, minus 4 times A is 1, times C, and C is 121. So 4 times 1 times 121, that's 484. 484 minus 484 is 0. So when we do this in the quadratic formula, we're going to have square root of 0. Remember, anything plus 0, that's the same thing, it's the same number as anything minus 0. Like if that were 8, you have 8 plus 0, and 8 minus 0, what do those both equal? They both equal 8. So this means we're only going to have one real solution. 8 plus 0, 8 minus 0, for example. Alright, that is the quadratic formula. It's negative b plus or minus the square root of b squared minus 4ac. It's an important formula that's used a lot in algebra, and it's good to know it.